on, you can consult example 3 and 4. But if I have to point out one of the worst section in this book, I would say this is the section.
This is the worst section.
The worst section. If there is a worst section, right?
Okay.
It could be reorganized. You can look at the example 3 and 4, you know why. Okay? I'm going to directly use the problem, okay, to help you understand the 3 ways of doing this, the diagram. Okay, and C, the third way of doing this is construct the B, the matrix B, column by column, okay? Column by column. So now, before I do 22, I like to start on it, but I need to do one thing. I want to go to this box first, okay? So I want to read this again. What is the meaning of the capital B, this matrix B?
It's a different T.
No, different basis.
Oh,
okay?
sorry.
Originally, this T is defined by AX, right? So this means T is, so TX is AX. That is actually relative to this basis V1, V2, standard basis. So what is the A? A is
The inverse of T.
A is, no, hold on. A is the matrix of T relative to the standard basis. So we have a name for or interpretation for capital A. And then what is capital B? Capital B, that's the matrix of T. Again, matrix of T, but relative to the basis B, right? V1, V2, not the standard one. So how are they related? So, in terms of formula, it is just B times, we are looking for B, such that B times the coordinate vector of X equals the coordinate vector of Tx. So how do we find this B? Well, they said, here is how you find it. B has a formula. So I'm going to explain this formula to you. It is quite complicated looking, right? I only look, the looks is complicated. Actually, it's not. This matrix has, in our case, n equals 2, right? 2 columns. So this is just one column, right? And then this is the last column. Many columns. Look at the first column. What is it?
It's V.
You know what T is, right? Linear transformation given, defined by AX. So instead of X, you put V1 in there. So that's T times V1, right? And then bracket, and then subscript B. What does that mean? What is this? Can someone call me, tell me, not call me, okay. Tell me.
Vector 1.
Vector
1. Coordinate.
Tell me what that is. Yeah, coordinate vector, how about we add vector, right?
Mm-hmm.
The coordinate vector of what?
Of T.
TV1, right?
Mm-hmm.
So, what do we need to do? You give me T, right? I'm going to apply this to V1 and then find the coordinate vector, right? And then I do the same thing, TV2, coordinate vector. Now I have 2 vectors, put them in matrix. First column, second column, right? Then I have the B for n equals 2. How about that? So now are you convinced that this is only complicated or sophisticated in its looks, right? So actually, if you use words, it's very straightforward. So why? That's the proof. So for one time, let's prove one more time. I think we did something before. So we want to show this. So how do we do this? You begin with x equals c1 v1 plus c2 v2. How about that? So n is 2. So I just go to the last one, c2 n2, right? Okay. Now you apply the t to it. So how do we do this? There will be t to each term, right? T is linear, so t to each term. On each term, t skip the scalar c1, c2, right? So that goes as t v1 and with a coefficient c1 plus c2 times t v2. And then we put brackets around them and put the subscript b. Now remember one of the two, or actually we combine, we use those two linear properties. So taking these brackets, the bracket into each term, okay? And then skip the C1 and C2. So that's what we did here. Now you rewrite this linear combination as a matrix times a column. So let's do the simple part first. What is the column? What is the column? You, everyone, help me. So remember what I'm saying? The column is here already. I just need you to tell me. C1 times this vector plus C2 times this vector is a matrix times a column. The column is C1, C2, right? How about the matrix? This is the first column. This is the second column. When n equals 2, that's done, right? So now we have proved this, and we are going to use it, okay? So as promised, I'm going to directly work on the problem. So 22, right? So let me write down this problem. A is 1, 1, 1, 1. C1
You're like, yep.
1, 1. V2 is 1 minus 1. Okay. So here is the problem. We have a t. Tx equals ax.
Yeah.
Where this a is the matrix 1, 1, 1, 1. Then we have a basis. A basis that's v1, v2, right? v1 is 1, 1, v2 is 1 minus 1. So find B, the matrix of T relative to this basis V1, V2. So that is the problem, right? So how about we do it 3 ways? A. B is S inverse AS. So what is S? Yeah. Here, so this S is B1, B2. So S is 1, 1, 1 minus 1, right? And then A 1, 1, 1, 1. And then I need to put minus 1. 1, 1, 1, minus 1. So that's S, right? S inverse, right? Okay. So how about this? I leave it for now. If I have time, I'll work it out, right? But I already told you how to find this inverse, right? Then you just multiply any way you want. You can do these two first, yeah? Then you do this one, right? Multiply them together. So you get B. The second way, they say use diagram. So I'm going to change a little bit. I'm going to do this C first. How about column by column? So I do C first. Column by column. So how do we do it? This is important, okay? Things like this. It's very basic. I already simplified, so without going through those two examples in the book, okay? So after you see this, you go back to read, you can see why I want to do it this way, other than following the textbook, right? So here, column by column, how do we do this? TV1. What is TV1? That's A times V1, right? Okay, so A, 1, 1, 1, 1 again. V1, that's 1, 1, right? 6 ones there. So you take back product, you get 2, 2, right? Here is the key. Here's the key. After you get 2, 2, what do? You need to remember we want to find the coordinates, right? Coordinate of 2, 2, what is it?
2, 2, X. X2.
So I need to write this as C1V1 plus C2V2. So here is the key step. So it doesn't matter it's TV1 or TV2 or anything. You have a vector. To find its coordinate vector, you just write the linear combination, right? C1V1 plus C2V2. So you need C1V, C2. So how do we do that? This is here. It's convenient for to find out, to observe that 2, 2 is 2 times 1, 1, right? And then 1, 1 is 1. You need to always go back to see what are your vectors, V1, V2. This is your V1, so 2V1. Now, what do you do with 2V1? Well, you add 0V2, how about that? Why do I need 0V2? Because I need C1V1 and C2V2, right? No V2 means 0V2. So now I have the coordinate. Can someone tell me what that is? 2, 0. Yes. So next time, you don't need to wait for me to back you, okay? You just.
Could you show to the brackets?
Okay, how about now? TV2. You know how to do TV1. You should be able to do TV2, right? In fact, you know how to do 5, 7, 9 in terms of those two vectors, V1, V2, right? As in example 1, you know how to do the rest. All the things are the same. procedure-wise. So here, to find this, what do you do? So I'm going to wait.
A times V1.
Yeah, TV2, A times V2.
Yep.
A is that thing again, right? And V2. 1 minus 1, okay?
1 minus 1.
So what do we get? 0, right?
Yeah.
0. So how do you can tell in two different ways. You can use combination. 1 times the first column
1 times 1.
plus minus 1 times the second column. That's 0. 0, 0, right? So 0, 0, what do you get?
0 V1 plus 0 V2.
Yeah, 0 V1 plus 0 V2. So now what do I put in here?
0 0.
0, 0. Yeah.
Total.
Okay, so what is B? First column is 2, 0, right?
Second column 0. Yeah.
Second column 0, 0. Okay, so how about this? Let me give you a couple of minutes. You work out this. Okay? See if you are getting the same beat. Okay, can you try this?
Someone said no.
Just work it out, right? So I can rest.
But spring break is so fun.
Regroup, right?
Regroup, recuperate. Yeah. It's not really spring break, it's spring work. Lots more money to be made.
Okay, so you have the matrices, right?
Professor, we can't see what you're writing.
Oh, I'm not writing for you.
Oh.
So you are still working on that, right? Okay. I'm preparing, I'm not sleeping.
Yeah.
Correct? Very good. Okay. How about diagram? Anybody likes diagram? Okay, so let's look at this diagram. So I'm going to do the same thing, more or less same thing, but without this using the exact example. Okay. So the diagram I'm about to do is based on the problem number 22. Okay. So we continue. Third way of finding the B. We already know what the B is, right? So the commutative diagram goes like this. You begin with X. So I could put arrow there, but we don't really need to do this. Too many arrows, okay? So on the first level, you have two columns, two items. Write down X as C1V1 plus C2V2. And this arrow means transformation T. T applied to X is C1 times T applied to V1 plus C2 times T applied to V2. So just simply put a T on each term, right? And then skip the C1, C2. And now we have these two arrow down arrows. That means taking coordinates. So what is the coordinate? Okay. C1, C2. What is the coordinates of this? We go to each one, right? We put the bracket on Tx1, Tv1, sorry. Okay. And then after I found this, I can find this B. So B. So B times this should be equal to this. So the key is we need to find this, right? But this is basically what we did in column by column method, right? So remember, you have seen this. The difference is when we do column by column, we do this each term separately, right? We do TV1, and then we do TV2. Here you have this whole thing together. Both TV1, TV2 use this formula. So, to continue, I need to find P, X, P of X. I'm just about copying down the left hand side and then C1, and then I need to find TV1. So how do I find TV1? Coordinate. So then I need to put it in there, right? So remember that that's what we have here. TV1 coordinate, right? So how do I find it? I need TV1. But that goes back to AV1, right? Remember, we already have it, right? If we didn't do it in this order, then you do it now, right? You do AV1. So that is 1, 1, 1, 1 times 1, 1. What are we getting? 2, 0. 2, 2, right? 2, 2. And then what is the coordinate? Remember 2, 2? 2, 2 is 2v1, right? Plus 0v2, right? So that's 2, 0. 2, 0. Plus. So we need to do C2, and then I need to put TV2 B in here, right? So for that I need TV2, but that is AV2. A is 1, 1, 1, 1. B2 is 1 minus 1, so we get 0, 0 again. 0, 0 is the vector. It is 0, V1 plus 0, V2. So what is the coordinate? 0, 0. So we put 0, 0 there. Okay? Now, what we have is, I need to write this as a matrix times C1, C2. So that's what we need to do. After you find Tx coordinates, which contains C1, C2, right? Because you start out from x equals C1, V1 plus C2, V2. We go to the right. So we still have C1, C2. So we are going to write this as B times C1, C2. Remember, that's the diagram. On this side, we have C1, C2. B times, so should be whatever we get, right? We already get something. What do we get? C1, 2, 0 plus C2, 0, 0. You need to write this as a matrix times C1, C2. What is this matrix?
2, 0, 0, 0.
Yeah, 2, 0, 0, 0. So that is B. So we find B. So that's the commutative diagram. Commutative basically means here you can start from here. You go this way. That's one way. Go this way, another way. Still arrive at this right lower corner, right? Now, how about the S inverse AS? That also can be derived by the diagram. So here is the diagram for the formula, S inverse AS.
That's confusing.
Okay? So, again, you begin with X. Begin with X. Going to this side. The difference between this one and the previous diagram is here we have the definition for T defined by A, right? We put an A here. So this is more specific. For some other problems, we don't need an A. They give you an A, then you can use the formula. So you do the same thing, you go to Tx equals Ax. Then you need to find the coordinates of Ax. So going back this way would be the coordinate. But in this diagram, we are going up. We're going upward. Okay, you see the arrows? These two arrows go up. So that means they go from the coordinates. So remember here, brackets with a B, right? On this side, bracket with a B. These are coordinates. From the coordinates, you go back to find the vectors, x and tx. So the diagram, you remember commutative, you can from one point to any other point through two different ways, right? So this time we begin with the coordinate of x. So here, the left lower corner, this node, you go up and the right to arrive at the ax, right? Ax. It is equal to, if you go to the right, use b first, right? B times this then you go to the right lower corner, and then go up. So you arrive at the same thing. That means going these two different routes, you are getting the same thing. They are equal. Okay, so how do we go from the coordinates back to the vector? That's s, right? Multiplication by s. So s times this coordinate, and then followed by this a. So a times s times this, right? You follow me here? Okay. So we begin with this coordinate of b, right? So, and then you have s applied to this. So, and then followed by a applied. So as and b times this one, and then sb. So as and sb are the same because they both lead to this one. So that's why as equals sb. From here you get b equals s inverse as, right? So you have b, and then you can also have a in terms of b. There will be s times b times s inverse. So all are based on this observation. You're going this way and going that way, you'll get the same thing. Okay? Alright. Okay, so you are equipped with weapons, right? To do all these homework problems. 3 different ways. Okay? So in exam, maybe I ask you only one way, right? So, or just find it without specifying any ways, right? So how about the first group? The first group, first 2 groups, you find coordinates for given vector x relative to a given basis b, right? That's v1, v2, or v1, v2, v3. So most of them are v1, v2. I don't see any v1, v2, v3. Oh, here number 13, yes, v1, v2, v3, right? So they are similar. And then another type of problem is given the coordinate vector and then recover the coordinate. Recover the vector itself. So that's on the let's see. In exercise 25 through 30, find matrix B. With the linear transformation Tx equals Ax with respect to this basis. So for these problems, 25, you can do exactly the same way as in the first group, the group we just studied. But then they have some problems that are bigger, right? A is 3 by 3, and then there are 3 vectors. They did not specify the way of doing this, right? Just do it anyway. I am looking for those problems where you find the vector. So looks like they do not have a group of problems that ask you to do something. But in this problem, so problem 44, they do ask you to find x given the coordinate, right? Given the coordinate, find x. So these are the homework problems. Okay. So we'll see you again on Yeah, on the Tuesday, we're going to have a review and the new material.
So, the next exam is change 3.1 to 3.4.
3.3, right?
So we're doing
So,
one.
3133.
So it's 3.1, 3.2, 3.3. Okay.